Hey guys, so we are in week 6 of our distance learning and we're going to kind of switch gears. We were talking about exponents a lot, so now we're going to start talking about radicals. So the first thing we are going to do, kind of like a warm up, is we're going to go ahead and list the perfect squares from 1 to 400. Now, if you don't remember what perfect squares means or what that is, a perfect square is when you multiply the same number by itself. That result, that solution is the perfect square. So 1 times 1 is 1. 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. So we're going to go through and list all the perfect squares. So if you need to, what I would say is just do 1 times 1, 2 times 2, 3 times 3, 4 times 4. And you're just going to go through and list all of those up to 400. Okay, so we can go ahead. If you want to pause this, try it on your own, and then see what I write out. You can. I'm not going to walk through it because I know a lot of them. So maybe try to pause this, do it on your own, and then play and see if you have the same ones as me. Okay? Okay. So I kind of was writing a little too big, so I ran out of some space there. But you should be checking yours to make sure you have all of them. I'm not expecting you to necessarily know every single one. You should 100% know these ones though. You should know that they are perfect squares and you should know what the square root of them would each be. So like the square root of 49 is 7 because 7 times 7 gives you 49. Hopefully this is not something that is necessarily brand new to us. We should have been exposed to square roots hopefully at one point, but if you were not, then you'll have a lot of time to be able to ask me a lot of these questions. Okay? So we have a couple definitions that we need to go over. Okay, so the first definition that we are going to look at is just radical. What does radical mean? And radical is the entire expression. So the radical is this entire thing. So when I say we're dealing with radicals, I mean we're dealing with that entire expression, the square root of something. So the radical sign is just the actual root sign. And if you notice, I'm doing it in different colors so I can highlight everything. So that actual radical sign is just the root symbol that we see, the square root sign. Then we have something, and this might be new for some of you. It's called the radicand. And the radicand is the number that is underneath the radical sign. Okay, so that would be here. And we're not going I know I have an X there, but that's because it could be any number. It could be 4, it could be 12, it could be 15. Okay, it doesn't have to be a perfect square. It's just that number that is underneath there. Okay, and then the index is something that we're not really going to deal with, but I want you to at least have heard of it. It is the type of root you are taking. So we're only ever going to be dealing with square roots, but you could technically find cube roots. You could find fourth roots. You could find fifth roots, which probably sounds very weird. I don't want you to stress about any of those. We're just going to focus on square roots. But one thing I do want to point out is something we never write in there, but it's always actually there. Just like we would never write 1x, we would just write x, or we would never write x to the first, we would just write x. Same thing goes for the index. When we're taking the square root, there's technically a 2 up there. Square is 2. Okay, when you square something, you raise it to the second power. When you square root something, it's to that second. Okay, you're taking the second root of something. Okay, so we just never write that 2 there, but it is technically there, and that's what our index is. Okay, So now we're going to get into some examples of just evaluating a radical, just simply evaluating it. Okay, so we're going to start with three perfect squares here. So when you're dealing with perfect squares, you think of 144. Let's say you didn't know that that was a perfect square. You can always try putting this into your calculator. So if you go to your calculator and you look on it, you should have, for most of you, some of your calculators might be different. And if that is the case, we will figure it out. Honestly, I would say Google it. Type the name of your calculator, which is always at the top, and then type that, how to find a square root, and it'll walk you through the steps. But for most of you, what you will have to do is press that second button that's in like the top left-hand corner. And then you're gonna have an x squared button. And if you look above it where the second things are, you should see a square root symbol, and you'd be able to click that. For some of you, you'll have to type the number in first and then do second. And then that square root symbol, for some of you, you'll have to do the square root symbol first and type the number in underneath. It just depends what type of calculator you have. The older ones, you'll do the number first and then do the square root symbol. For some of you, it'll be the square root, then the number symbol. You might just have to play around with that to see which way it's going to be. Okay? But once you do the square root of 144, if you didn't know if that was a perfect square or not, you could put that into your calculator, and when you do that, you would see that it gives you 12. So the square root of 144 simplified is 12. For number 2, the square root of 64, if you didn't know if that was a perfect square or not, you type it into your calculator. You would find out that it would be 8. And again, the reason why it's 8 is because 64 is 8 times 8. That's why 64 is a perfect square, because it's the same number multiplied twice. Over here in number 3, the square root of 121 is 11 times 11, so the square root would just be 11. Okay, and hopefully I'm like over explaining this and you guys kind of already have a good understanding of a lot of this stuff. That is my hope, at least. Okay, so now we're going to be moving in to what happens when I don't have a perfect square. So it says the product property of radicals. The square root of a product equals the product of the square roots of the factors. That sounds confusing. What it's pretty much saying is I have the square root right here. I have the square root of 242. What I can do is split this up into factors, and that's still okay. I can take the square root of its factors and multiply them together, and it would still be the same thing. Product means multiply. Okay, so if you were to try to type in the square root of 242, you would not get a perfect square. It would not just be a number. Okay, so then from there, what you're going to have to do is say, okay, well, let me try to think of the factors that go into 242 that are a perfect square. So that is where this list up here is really going to come in handy. So what I suggest you do is take 242 and you want to see what is the largest one of these numbers in the list that can divide into that. That's a factor of that number. And you would find out that it's 121. So I can split this up. This is the square root of 121 times 2. I multiplied that, I would get 242. So I can split it up like that. From there, I can say, well, I can split up even the square root to be the square root of 121 times the square root of 2. Then from there, what I can do is I know that the square root of 121 is 11. And then I would be left with the square root of 2. The square root of 2, even though you think it should simplify, you actually cannot simplify that. Okay? It would have to just be left like that. So that would be our simplified answer. You're still going to have a square root in there, but it's not as big of a square root. Okay? Okay, so we're going to get into those types of problems now, and that's going to be the majority of what we're looking at today. So how to simplify a square root. A square root is simplified when the radicand, remember the number under the radical, has no perfect square factors other than 1. So what that means is, like if we look up here in this example that we did, I did 121 and 2. I could simplify the square root of 121, that's 11, and I was left with the square root of 2. You would look at the factors of 2. It's 2 and 1. The only perfect square there is 1, but if you keep just taking a 1 out, it's not going to change your answer. So that's why it's saying that there cannot be any other factors underneath that radical that's a perfect square other than 1. If there is, that means you haven't simplified fully yet, and you have to keep going. So the key here is to find the largest perfect square that's a factor that can multiply into that radicand. Then you'll rewrite the radical as a product of those two and evaluate. Okay, so we're going to go through some example problems together. Hopefully it starts to make a little more sense if you're confused right now, kind of as we go. All right, so let's look at number 1. We're going to simplify the expression. The square root of 24 is not a perfect square. That was not in our list up there. So what I want to do is figure out what the largest perfect square is that is a factor of that multiplies into 24. So that is where you want to look at that list that we wrote up there. You don't want to just start picking random numbers. So you know that 1 is a perfect square, but we're never going to use that number. Then the next one is 4. Well, 4 times 6, that works. If you start going into your larger perfect squares, you'll notice that none of them go into 24. So what we can do then is split this up to be the square root of 4 times 6, which is the same as the square root of 4 times the square root of 6. From there, the square root of 4 we know is 2. The square root of 6, the only factors of 6 are 1, 2, 3, and 6. None of those are perfect squares other than 1, but we're always going to just ignore 1. Okay? None of those are perfect squares, so even though you think you should be able to simplify 6 more, you actually can't. So that is our final answer. Okay? So let's look at number 2 here, the square root of 500. So let's go up to our list here and let's try to figure out what is the largest perfect square that is a factor of 500. And if you kind of start looking through, there's probably going to be a handful of them, but you notice 100 here. 100 can definitely go into 500, and that's a pretty big number. So if I were to do that, I would have the square root of 100 times 5. So the square root of 100 times the square root of 5. The square root of 100 is 10. 5, the only factors are 1 and 5. Neither one of those are perfect squares, so that stays. So my answer would be 10 root 5. Okay? Looking over here at number 3, this is starting to get a little more complicated because 108 isn't a number that we necessarily deal with all the time. So I want you guys to pause for a second, scroll up to that perfect squares list, and try to figure out what is the largest perfect square that goes into 108. Hopefully, as you were going through and you were testing some of the numbers, you figured out that the largest perfect square would actually be 36, because 108 is 36 times 3, which is the same as the square root of 36 times the square root of 3. Square root of 36 we know is 6. The only factors of 3 are 1 and 3. Those aren't perfect squares that we want. So the root 3 stays. We can't simplify that anymore. So that would be our answer. Over here in number 4, now we're starting to kind of add in an extra step. Now we have this 3 that's kind of multiplying out front. What we're going to do first is just deal with that radical part of it and multiply the 3 at the end. So 3 times, we'll just leave that there. The square root of 27, the largest perfect square that goes into that is going to be 9. So it's the square root of 9 times the square root of 3. If you notice, I kind of skipped that first step of writing it all down at once underneath one square root, and I went to just splitting it up. That's totally fine for you to do that. So then from there, I'm going to have 3 times, well, the square root of 9 is 3, so the square root goes away there. But then the square root of 3, I can't simplify, so that just stays the square root of 3. Now I can multiply 3 times 3. 3 times 3 is 9, and then the root 3 stays at the end. Okay, so we're going to pause here, and we're going to pick it up in the next video in just a second.